So this is the AQA November 2017 paper 2F full run through. Stop the video to check any of the questions before you do them, etc. And then just scroll across the video to see the answers or listen to the explanations. Hopefully useful to you. Okay, so the first question, how many minutes are there in 2¼ hours? Well, one of the facts we need to remember in the exams, guys, is that 1 hour is equal to 60 minutes. A quarter of an hour is equal to 15 minutes. So in total we've got 2 of these, which makes 120, plus the extra 15, which makes 135. So in 2¼ hours there'll be 135 minutes. Which of these numbers is half of a square number? Well, again, there's the key fact, so underline, focus our minds, we want square numbers. So we should be thinking to ourselves 1, 4, 9, 16, 25 and so on. The answer is to multiplying whole numbers by themselves. It produces a square number. So half of a square number, well, if we do the halving, then that's half of a square number, 2. So the answer will be 2. Circle the value of the digit 3 in the number. Well, if I write that number out a little bit so we can see what's going on, we need to remember that this is our ones column, our units column, this is our tens column, this is our tenths, and this is our hundredths. So it says circle the value of the digit 3. Well, in that particular position, it's worth 3 hundredths. Okay, so the value of A is double the value of B. Circle the correct formula. So again, identifying under you what. Double is the important thing here. Double means times by 2. So the value of A is double the value of B. So A is equal to 2 times the value of B, which in small letters would be, without the times sign, would be 2B. So A equals 2B. Simplify, so in other words, write less. Y times y, well, when you times something by itself it's the same as squaring, so this will be y squared. The other way of thinking about this is both of these have power 1. Anything on its own, any letter, any number on its own is always power 1, and when you're timesing with the same bases of y's or x's or the same base numbers, then the powers get added and 1 plus 1 is 2. Simplify, again, write less, so we look at these terms and we see if there's any like terms. And like terms are things like x is equivalent to, well, they're like 2x's because they're all about power 1s. X squared, again, power 2s, so they're like terms. Numbers on their own, so 1, 9, they're like because they're just numbers. So like terms, so we look in here and we can see there's 5 A's, take away an A. One of the things you've got to remember about this simplifying with algebraic expressions, guys, is that you're looking for the sign, the operation in front of the term. Although this one doesn't have an operation in front of it, it is positive by default. If there's nothing in front, then it's telling you it's positive. So it's either a plus or minus that separates terms, of course. So we've got positive 5 A's, take away an A, so that leaves us with 4 A's. So we've got 5A, take away an A. Well, that's 1A, so again, letters on their own is one of them, so 5 take away 1 is 4, and talking about A's, so 4 A's. And then we've got positive 2 plus 9, which makes, so that's 4A, and then positive 2 plus 9 makes positive 11, so we end up with plus 11. Okay, so the table shows some information about birds in a garden. Okay, that's fine, just telling us how many there are of each. It says draw a bar chart. Okay, so we've got to remember a bar chart is going to have frequency up the side. So in this case the number of birds. So frequency means total, so I might as well give it a label because it's talking about birds. And along the bottom here will be bars, and each bar, because it's a bar chart, must be separate to represent each variable, each item. So we must remember they've got to have separate bars, and the bars are the same width. Okay, so we've got to think of scale when we do graphs and charts. So the scale, so the largest number we've got to plot is 5, so we can see on this graph paper it's very simple. The scale is going to be 1 square equals 1 bird. Okay, so if we get our rulers and we draw an axis, we've got 4 to plot, so 1, 2, 3, 4. Yep, so we can draw this going inside. Just remember your exam papers are photocopied, guys, so it's useful to make sure the lines are slightly thicker, just so it highlights what's going on. And we've got a frequency, so we've got to go simply up to 5, so 1, 2, 3, 4, 5, 0. And label, of course, really important with graphs and charts. We always label, so number of birds or frequency. And so we've got a bar going to 2 for the robin. For the sparrow, we've got 5. Again, remember to leave the gap between each bar and to make sure the gaps are all equal and the bars are the same width. Wren of 3. And a lark of 1. Okay, so this was the robin, sparrow, wren, and lark, and label type of bird. Okay, we should give it a title, so bar chart to show types of birds in a garden. Okay, and because it's going to be photocopied, guys, it might be useful just to put some hashes in. Don't spend ages colouring in, because obviously that won't get you extra marks as such. Just quick. So that's what you should be thinking about when you're drawing a bar chart. Key thing is to remember, always label your axes and always think of scale when you're dealing with graphs. Okay, so Eve has these coins, Ola has these coins. Eve gives 3, so there's the key information, so we underline. So now Ola has the same amount as money of Eve. Which coins? Okay, so the first thing to do, of course, is about money. So it's about amount of money. So underline, what do we know? Well, we can add up. So £1.50, £1.53 so far. And here we've got a £2, £3, £3.50, £3.70, £3.90, £3.97. Now, because they're going to have the same amount, then basically we'd add up these and halve them, and that'll tell us how much each person should get to have the same amount. So 397, 153. It is a calculator paper, so it's a fairly simple calculation, but always use a calculator when you've got to do things. Did that wrong. So clear that. So 397 plus 153. Okay, so £5.50. Okay, and then divide that by 2. Okay, so 250, 275 each. Okay, so then we do 275, take away the £1.53, and then that'll tell us how much extra she needs. Okay, so 275 take away 153 is 122. Okay, so we need it from Eve. Okay, so Orla needs £1.22 more to make her money up to the £2.50. Sorry, £2.75. And so it's 122. So she gives 3 coins. So that's going to be the £1 coin, the 20p, and the 2p. Okay, so the answer to that question then, £1, 20p, and 2p. Alright, the next one. Okay, so dry cleaning shop, normal price, first suit is normal price, second suit half price, and dresses, normal price is at 3 for the price of 2. Okay, so we're going to be careful of these 3 for the price of 2 offers. Okay, so we've got two suits. So the first suit is normal price. So the first suit will cost £12.50. The second suit is half price. So we need to make a note. So that's going to be £6.25. Okay, so, and she's got 6 dresses. So it's 3 for the price of 2. So when it's 3 for the price of 2, it will be 6 for the price of 4. Double that, double that. Okay. So we recognise then that the dresses, we're going to have to do 4 times £9.75. Okay. So 4 times £9.75. So that's £39. So total price is going to equal 39 plus £12.50 plus £6.25. Okay, so like a lot of things with calculator papers, guys, leave the previous answer in if you know you're going to use it, so you type in it again. Any second saved, always useful. Plus £12.50 plus £6.25. Okay, so £57 and 75p. That's what you put on the answer line. Okay, so that's how that question could be done. Just got to be careful of these 3 for the price of 2 offers and just think how you're going to work that through. Okay. Alright, so Carl has twin sisters, same age. The sum of the ages, so again, we underline what's important, triggers, and then we ask ourselves what do we know. The U what, so U what. Always a useful thing to remember. There's a video on that on my channel if you want to check what what's all about. But it helps us think through problems. So we underline, trigger things, keywords, and then we ask ourselves what do we know, because we've underlined it for a reason. So what do I know about that? So twin sisters means same age. Alright, the sum, so that means add total. The ages of Carl and his twin sisters is 39. In 4 years' time, the twins will be 18. Okay. So at the moment, they're 14. So now they equal 14. How old will Carl be in 4 years' time? Okay, so we need to work out the age of Carl now. So as we don't know something, the H in U what is help yourself. So if you don't know something, call it X, create an equation. Don't know something, call it X, create and solve an equation. To find its value. Okay, so the sum of ages of Carl. So we're basically going to say that let Carl's age equal X. So we know that X plus the twin sisters, which we know are 14, and that must equal an answer of 39. So X equals 39, take away 28, because we know that we've got 28 there, so if we take that away from 29, that'll tell us 11. So Carl is 11. In 4 years he will be 15. Okay, so that's how we could do that question. Okay, so again, one of the angles in a triangle is 60 degrees. Okay, so different types of triangles. So it could be an equilateral triangle where they're all 60. So again, the U what? We're underlining something, and then we're underlining it's important, then we ask ourselves what do we know. So it could be an equilateral triangle. It could be an isosceles triangle, where that's 60 degrees. But if that's 60 degrees and it's isosceles, it means the other two angles are the same. So if that was 60, 60, 60, alright, so it can't be isosceles then, because every angle would be 60. So if I put 60 there, that would be 60 and that would be 60. And if I put 60 there, that would be 60, which makes that 60 anyway. So isosceles it definitely cannot be. Okay, so could be scalene. So one of the angles could be 60, that could be 100, and that could be 20. So it can be scalene, and it could be a right angle, because that would be 90, that would be 60, and 90 and 60 is 150. Angles in a triangle up to 180, so that could be 30. Alright, so the triangle is equilateral. Okay. The triangle has at least one other acute angle. The other two angles are okay. So the triangle is equilateral. Okay, it might be true because we've seen that it could be scalene and it could be right angled. So that might be true. The triangle has at least one other acute angle. Well, again, from scalene we can see that the triangle has at least one other acute angle. Acute is less than 90, so that means less than 90 degrees. 60, 60, 60, all acute. If that's 60, then the other two angles could be 120 in total. The biggest then that could be is 119. The smallest it could be would be 61. Yeah, so that must be true. So because we've only got 120 left, yeah, so that must be true. The triangle is right angled. It might be true. The other two angles are each less than 60 degrees. Well, we've seen from the scalene that's not necessarily true. The other two angles are each less than 60. Each less, so that means both, doesn't it? So the two angles are each less than 60. No, that cannot be true, because if they were both less than 60, then it's less than 120 in total, and one angle is definitely 60, so the other two have to be at least 120. So it says each less, so that cannot be true. Okay, so that's what I think then, guys. Okay, so which of these number has exactly two factors? Exactly two factors, so that means prime numbers, because prime numbers are defined as those that have exactly two factors. Must remember, factors are whole numbers that go into other whole numbers. So we're looking for prime numbers. Well, 6 isn't prime because it has 1, 2, 3 and 6 as factors, so definitely not. 7 is prime, so that's definitely that. That's got 1, 2, 4 and 8, and that's got 1, 3 and 9 as factors. So that's the only one that's got two factors. Okay, so we're going to work out this. Well, it is a calculator paper, so we'll shove that in. So square root. Oops, calculator on across. Okay, so we're doing 7.5 squared plus 18 squared. Alright, don't forget to make sure you've got a scientific calculator and you're very familiar with it in your exams. Just remember that the squared key is x for the little 2 on most calculators. Okay, so we press enter, and so the answer is going to be 19.5. It then says use a calculator to work out the exact value of that. So again, calculators have fraction keys, guys, so look for the fraction key and work out and make sure you know where it is. So this is a fraction, so we can then type in the top part of the numerator 18953 times 437. Use the mover down, so the denominator 11, enter. Okay, so 752,951. Alright, so just check through an estimate. That seems reasonable. So that's close to 20,000, that's close to 400, and that's close to 10. So 400 divided by 10 means we've divided that by 10 and divided that by 10. And we've got 4 2s are 8, and we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so 800,000, 752,951. Yep, that's reasonable. Okay, so use approximations to check if your answer is sensible. Alright, so I've already done that. Okay, so 20,000 times 400 divided by 10 is approximately 80,000, or 800,000, sorry. Okay, so that should get the marks for that question. Alright, so we've got somebody who's selling lawnmowers, and the table shows the number he sold each quarter for 3 years. Okay, in which year did he sell the most lawnmowers? Alright, so year means that we've got to add up all the quarters. Okay, so let's calculate a paper, guys, so use it. 64, 50 and 5, so 136, 9 plus 72 plus 61 plus 1, 143, 19 plus 58 plus 53 plus 2, 132. Okay, so the answer was 2015. Got the largest number. Okay, he uses the table to decide the number of lawnmowers to stock each quarter. At the start of which quarter should Chris stock the most lawnmowers? Okay, so when we look at this, that's quite low. Okay, so if we come down here, we can see that we've got 136, 186, 194, and here we've got 50, 111, 114, 164. So quarter 2 seems to be the one where he sells most. Okay, so quarter 2. Okay, so we've got a test. Section A is 80 marks, section B is 120, so 55%. So this tells us to do a calculation, and the quickest way to do this on a calculator, guys, is turn the percentage into a percentage multiplier, which is the decimal form of the percentage. So we get that by dividing by 100. So divide by 100, and then we times by the number of marks. So in this section, so we got 0.55 times 80, so 44, and in section B, 0.7 is 70%. We times that by 120, which gives us 84 marks. Okay, so to pass, Raya needs to score 65% of the total marks. Right, so in total, total scored, well, we add those up, so 128, 65% of the marks, so that'll be 0.65 times 200 possible, so that's 130 marks, so the answer would be no. So Raya needed 130 marks to pass, only scored 128, so did not pass. Our check, well, we could work out what 128 is out of the 200 as a percentage. And the way we do that is always fraction times 100. So fraction times 100 will always give us a percentage. And so we got 128 divided by 200 times 100 equals 64%. Okay, so again, both ways we can show that only got 64% or got 128 marks, so didn't pass. Okay, so I've got a wheel here, it's a circular rim and 8 spokes. The length of each spoke is 37, so under you what? Help yourself, add things to diagrams. Okay, so we're adding on 37 centimetres. Work out the total length of the rim. Right, it's a circular rim. So again, that tells us that we're dealing with circumference because it's mentioning lengths. And we need to remember the formula for circumference is equal to pi times the diameter. Okay, so the diameter is going all the way across from one side of the circle to the other through the centre. And therefore the diameter is going to be 2 lots of the 37. So 74 centimetres. We've got the total length of the rim and the spokes. So we've got 8 spokes, so total length is equal to pi times the 74 for the diameter plus 8 lots of 37 because there's 8 spokes. Okay, so we've got pi times 74. Learn where your pi key is on your calculator, guys, it's useful. And then we're adding 8 times 37. Alright, most modern calculators will handle that calculation through BIDMAS, so it'll do the timesing first and then do the adding. So we should be able to type it in as it is. So the answer's 528.5 centimetres. So what I've done there is I've just rounded to 1 decimal place to make it sensible because the numbers we were dealing with were whole numbers, so you really can't create more than 1 decimal place of accuracy to be sensible. So that's how that question could be done. If we want to check it, we could do the calculation separate, so 74 times pi, enter, and then we could add on that answer to 8 times 37, enter, so 528. Okay, so again, underlining A, remembering U what is to answer the question, T is to test if it's reasonable. So we go around thinking to ourselves, yeah, we've got 8 spokes, that's reasonable, we've done that calculation, each of them's 37. We've used the correct formula for this, and we've done the pi times the 74 because we've checked that we've done the diameter. So we've tested our answers reasonable. And the question mark is all about going through and ticking off every sentence. Have we recognised all the information and done it? So a wheel is made of a circular rim and 8 spokes, yeah, we did that. The length of each spoke is 37, yeah, we put that on the diagram to help ourselves and thought about how we use that to get the diameter, because that gave us the radius. And then we've worked out the total length of the rim, yeah, we've done all that. So we've gone through that question using the U-What principle. So U was underline, the H is what do I know. So in other words, I've underlined something just because it's important, and then I've put it onto the diagram by helping myself, then I answered the question, and then I tested it out. Okay, so the next question then is all about formulas. So we know a formula has a subject, and we do something with other variables to get the value of that subject. So, telling us some information, so show that at negative 40 degrees C is the same as negative 40 degrees Fahrenheit. Okay, so this is telling us that C is equal to negative 40. Alright, so we've got to be careful, guys, on our calculator. So we know that to get the Fahrenheit temperature, it tells us to do 1.8 times. Notice I put that in a bracket, so substitution, it's always best to put the letter as a bracket and then the number inside. That helps you to limit mistakes when using calculators, and we then added on 32. So we should be able to type that in the calculator as we see it. So we've got 1.8 times bracket. Now you've got to be careful, guys, that you use the negative key on the calculator when you're dealing with negative numbers, not the minus key, because negative numbers are different to minus. Minus means take away. So we've got a negative key here, which is the negative sign inside a bracket. That's usually what it looks like on most calculators. So we're going to put the negative 40, we're going to close the bracket, and then we're going to add the 32. Okay, so that gives us negative 40. So that equals negative 40. Alright, so when it says show that, it means you've got to actually show what you've done. So in other words, you show the calculation you're going to do on your calculator, and then prove that you get the same answer. Okay, so part B says the temperature is negative 15 degrees C. Nick says because the temperature is negative in Celsius, it must be negative in Fahrenheit. Is he correct? Okay, so well, there's lots of ways of thinking through this. We could say F equals 1.8 times negative 15 plus 32. We could work that out. So change that. Okay, so clear that. So 1.8 times bracket negative 15 close bracket plus 32. So that's positive 5. Fahrenheit. Okay, so Nick says because the temperature is negative in Celsius, it must be negative in Fahrenheit. Is he correct? No. No, he is not correct. As negative 15 degrees C equals positive 5 degrees Fahrenheit. Okay, so that's how that question could be done. Alright, so this question talks about 5 cards. One of the cards is removed, so that means taken out. The mean, right, so this is telling us something. The mean average is where you do the add all numbers up and divide by how many numbers you've added. In other words, the fancy formula is x is equal to the sum of the numbers divided by the total frequency, the sum of the frequencies. So the total divided by the number of numbers. Okay, so what have we got? The mean of the numbers is remaining 4 cards is 6. Okay, so they're telling us that 6 is equal to the total divided by 4, because we've only got 4 cards left when we take one out. We can then swap this about to remind ourselves that the total left must equal 6 times 4, which is 24. Okay, so which card is removed? Well, we've got to work out which of these. So if we add all these together, so we've got 20, 27, 32, 33. I want to leave myself with 24, so if I take away 9, I get 24. So it says which card was removed. 9 was removed. Okay, so that's how that question could be done. Again, it's just important that you remember all these formulas and facts. Okay, then we go through, tick off, yeah, done that, which card was removed, was surely working, yeah, done all that. Okay, so next one. Divide 120 in the ratio 1 to 4. Okay, so lots of strategies for ratio. Quite often when you're doing sharing divide problems, then thinking of these as fractions. So that's worth 1/5 and that's worth 4/5. So 1/5 of 120 is 120 divided by 5, which is 24. So 4/5 of 120 is going to be 4 times 24, 96. Okay, so the answer is 24 and 96. Okay, so because we wanted to check, then if we divide both of these by 24, we get 1 and 4. Okay, so that's our answers. Alright, so write the ratio 74 in the form n to 1. Well, quite often it's useful to write ratios in the order they give you them, and then write underneath what they're asking you to do. And then there's a thing called equivalent ratios. And when you're doing equivalent ratios, we're just looking for a multiplying factor or a division to get from one number to the other. And do the same then to all sides of the ratio dots. So here we've got to divide by 4, and then we're going to divide by 4. And 7 divided by 4 is 7 quarters, which then becomes 1 3/4, or 1.75. Really up to you how you want to leave your answer. So this side is 1.75 and this side is 1. So that's called a unitary ratio. Okay, so we've got the method of sharing and division using fractions. So make the so 1 plus 4 gave us 5, so that's why I was dealing with fifths. And 7 to 4, write the ratio, and then underneath it write down what we know so far. Think about how one side of the ratio could turn into the number that we've been given, and then the other side must do the same to keep them equivalent. Okay, so in 2015, per month, okay, so 2% increase, so 100% original salary plus 2%, that gives us 102% now, which is equivalent to multiplying by 1.02. Okay, so the calculation we can do from that sentence then is 1.02 times 1,350. So 1.02 times, clear everything, so 1.02 times 1350, so 1377. Worked 37.5 hours per week, worked 47 weeks, work out hands average pay. So in other words, average total pay divided by total hours. That's basically what it's asking us to do. Okay, so the total pay was 1377. Total hours was 37.5 per week times the 47 hours. So again, I've got a fraction key on a calculator to write that. So 1377. Use the arrow key to come down. 37.5 times 47. Enter. Okay, so the reason I'm hesitating, guys, is because 78 pence an hour is not reasonable. So I've tested my answer. I've read it through again. It's total pay for the year, because it wants the whole year. So I've forgot to multiply that by 12 because I want monthly pay multiplied by 12 months in the year. So okay. Alright, so fraction key 1377 times 12, and on the bottom 37.5 times 47. That's better. Okay, it's money, so 2 decimal places for money answers, so £9.38. The 5 is more than halfway on the thousandths, so it makes the hundredths go up by 1, so nearer to 0.38 than it is to 0.37. Okay, so £9.38 per hour. Well, that seems reasonable. The minimum wage nowadays is around £7 something, so that's why I kind of thought 78p, not reasonable. Okie dokie, so an experiment is carried out 200 times. The possible outcomes are, alright, so this is about probability. Experimental probability in this case, probability. So we're dealing with fractions or decimals or percentages, but fractions are normally the best way of doing it. So this is going to be out of 200 because it's carried out 200 times. Okay, and let me turn that into a decimal because it wants the relative frequency. So relative frequencies are the decimal version of a probability, the chance of things happening from an experiment. Okay, so this answer is going to be 54 out of 200, which is the same as 0.27. And because it was done 200 times, then we're going to do 200 take away 84, take away 54, 138, 62. So that's going to give us 62 of those, and then 62 over 200. 62 over 200 is going to give us 0.31. Okay, and our check is that all of these, because these are all the possible outcomes, then all our relative frequencies should add up to 1. So 0.42 plus 0.27 plus 0.31 equals. So 0.42 plus 0.27 plus 0.31, 1. So we can be happy that our check works. Alright, so experimental probabilities, we think of them as relative frequencies, the chance of things happening through an experiment, and it's basically the principle of probabilities. So probabilities, usually fractions, turn them into decimals by doing division. So 54 divided by 200 is 0.27, etc. Okay, altogether the experiment is carried out 500 times. How many times would you expect to get the K outcome? Well, we've got to remember that relative frequencies are probabilities from an experiment, so, or data collection in some way from books, whatever, surveys. And basically it tells us the chance of things happening. So for K, the chance of things happening was 0.42, which is 42%. So the expected outcomes for K were 0.42 of all the events. So we want 0.42 as a fraction of 500. Which is going to be 208, but we'll just check just in case I do something silly. So 0.42 times 500, 210. Yes, I did something silly, 210. Okie dokie. So that was the answer for that one. Alright, so this question talks about some populations and area squares. It's given us a formula to use, so it says the population density is population divided by area. Compare the population densities. So compare means work out both and then say something about it. So for the UK it's 64 million divided by 95,000, and for Germany it's 82 million divided by 140,000. So 64 million divided by 95,000. So 673 point, again one decimal place is sensible. Now don't forget, when you're doing comparisons, units are really important to do the comparison with. So this is 673.7 people per square mile, because you've divided people by square miles. And 82 million, 1, 2, 3, 4, 5, 6, divided by 140, 1, 2, 3. So 585.7 people per square mile. Alright, so those are the calculations, but it says compare them. So basically we're going to say that the UK has more people per square mile than Germany. In other words, it has a higher population density. Okay, so that's how that question could have been answered. Alright, this next question is one of those words that comes up every so often. Two main types of data there's continuous data, because this talks about discrete data. So there's continuous data, which is measured, can take any value. And then there's discrete data, which takes limited values. So in other words, there's a finite set of values. So for example, number of shoes. So you count them basically. Alright, so the mass of a television is continuous because it's something you measure, mass, so it could be any value. The time taken to deliver a television is also continuous because again you measure it. The height of a television is continuous because again you measure it. The number of televisions sold, well you count those, 1, 2, 3, so discrete values, you have only certain values of televisions, so therefore the discrete data must be the number of televisions. Okay, so this question talks about a single transformation, and that's what we've underlined. So what do we know about that? Well, there are 4 types of transformations for this exam. So rotation, enlargement, translation, and reflection. So that's what we know they're talking about. They're talking about one of those 4, because they said it's a single transformation. And we've got to ask ourselves what's happened to this shape. Well, we can see quite clearly that one shape is bigger than the other, so that means there must have been a scale factor, so therefore it must be an enlargement. Rotations, translations and reflections move shapes, but the shapes stay congruent, so in other words they stay identically sized, they're just in a different position from where they were. So this is an enlargement. So basically for an enlargement we need a centre and we need a scale factor. So the centre of enlargement, well, lots of ways of doing this, but generally you find corresponding vertices in the same positions as the shapes and you join them together. And where they cross is going to be the centre of enlargement. So that has coordinate 5, 1. So the centre is 5, 1. And scale factor, well again you can choose any edge and measure it either with a ruler or by counting squares. It's got to be the corresponding edge. So we can see in this one that the bottom edge here is 2, and we can see in this one the bottom edge here is 2, 4, 6. So to get from 2 to 6, now we've got to go back to the question. It says describe that maps triangle A to triangle B. So we're actually going in this direction. So in this direction we've divided by 3. So as a scale factor, then we recognise that that's going to be a fraction scale factor because the shape has got smaller. So divide by 3 is the same as taking a third of it. So the scale factor is 1/3. Okay, so it's an enlargement, centre 5, 1, scale factor. We go back through and check we've done what the question wanted. Maps triangle A to B. Yep, we've done that, A to B. And we found it's an enlargement, we've got the centre, and we've done a scale factor. Okay, so this graph shows information about prisms with the same volume. Okay, so there's the clue. I've got to remember that a prism is like any shape where it's a 2D shape extended in parallel direction where the two end faces are the same. So it could be that, could be any shape really, as long as the end faces are the same and the sides between them, the edges between the two end faces, are parallel. So prisms has the same volume, so in other words the area of cross section, so it's talking about volume, so we should be thinking of formula. So the volume is equal to the area of cross section times the length. So as the area of cross section increases, the length decreases. So that makes sense because they've kept the same volume. So these two numbers multiply all the time to give you the same. So this is going to be about inverse proportion, because as one value increases the other decreases. We've got a fixed volume, so it's inverse proportion. It says give one example to show the volume is 24 cubic centimetres. Alright, so that means we can choose any of these numbers on this line, and because it's the same volume, we've got to just multiply the cross section by the length, because that's what the volume formula is. And we can see then that if we go from 6 and 4, keep it simple, then this would work. So 6 times 4 equals 24. So volume equals 24 cubic centimetres. Alright, so we could have chosen anything. 8 times 3 is 24, 6 times 4 is 24. This is, this idea of inverse proportion is always where something stays constant, and it's the coordinates multiplied will always give you an answer of 24. Okay, so it goes on. The diagram shows a prism with a volume of 24. The height of the triangular cross section is h. Work out the height h. Alright, so then we know that the volume is equal to the area of cross section times the length. So we know from the question that 24 then must equal area times 5, because we've been told what the length is. So we can rearrange this by dividing by 5, and that tells us that the area is equal to 24 divided by 5, which is equal to 4.8 square centimetres. Alright, and we know that the formula for the area of a triangle is equal to a half of the base length times the perpendicular height. So we know we've got 4.8 is equal to a half times, well, the total of the base length is 6 times the height. So we know that 4.8 is equal to 3 times the height. So we divide by 3 to tell us what the height is. So the height must be 1.6 centimetres. Okay, so these are the kind of questions where, we've got the volume, we've done that, we've gone for the height, and we've worked it out. So these are the kind of questions where we are wise to write the formulas down, and we recognise the cross section here is a triangle, so we needed the formula for the area of the triangle, and put the numbers in, rearrange the information to get the value of the letter we don't know so far. So we didn't know the area in this case, so we got the answer for that, and then we knew what the area formula was, and then we rearranged this to get the answer for the height. Okay, so we've got a ball, it's thrown from a height of 15 metres, it bounces, okay, so logical, bounces less each time because of gravity. H1 is 3/4 of the original height, so this is telling us that we've got 3/4 times 15. Okay, so that's 45, 3 for 15 is 45 divided by 4 is 11.25, so that's 11.25 metres. Jack expects H2 to be 3/4, so work out the value that H2 expects. So basically we need to do 3/4 times 11.25. Okay, so just check that 3/4 times 15 just to make sure I made any silly mistakes. 3/4 is 0.75. Yep, 11.25, and then times that by 0.75 again. So 8.4375 meters. Alright, so that'll be the answer for that one. Okay, so when it was 3/4, we know the answer was 8.4375. H2 is 2/3 of H1. So if we do 2/3 of 11.25, so 2/3, if you want to do a fraction of anything, then press the fraction key, put the fraction in, and do a multiplication. So this will be doing 2/3 of 11.25, so 7.5. Okay, so how does this affect the answer to part A? The ball bites higher than you expected. The ball bites lower than you expected. Well, it's bounced lower, because he thought it was going to be 8.4, but it actually only got to 7.5, so it went lower, and we're showing our workings there. Okay, so next one, solve. Alright, so we've got to solve an equation, which means rearrange this to get the value of x. So expand the bracket is one way of doing this. So 12x, 4 times 3x, then 4 times 2, take away 8, is equal to 2x, take away 5. And there are lots of ways of thinking about solving equations, but generally it's about balancing the equals. Whatever this side is must equal whatever this side is. And if I take something from this side, I must take something from that side. If I add something to that side, I must add something to that side. If I times something by this side, I must times this by this side. You know, whatever I do, I must do the same to both sides of the equals to balance the whole thing. So we've got more x's this side, so it would seem logical to keep the x's positive. So I'm going to take the 2 x's out of this side, so I must take the 2 x's out of that side. I must remember that operation take away 5 means it's going to be negative 5 there, take away 5 there. I want x, so this take away 8 here is in the way, so to balance that out I have to make it 0 by adding 8. Do the inverse operations basically to cancel these through to whatever they need. So take away 8 becomes plus 8. So we have 10 x's are going to be worth, well, negative 5 plus 8, do on a calculator, but the answer will be 3. And because I know what 10 x's are, I want one of them, so I can divide by 10, and 10 divided by 10 is 1, so that gives me 1x. 3 divided by 10 is 0.3, so 0.3. Now, most of you won't do this, but really, guys, you should do the check. The whole point of algebra is that you get a value that you can use. Well, so the whole point, one of the points of algebra. So you can write formulas to represent things and model things as well. Lots of different things you can do with algebra, but you should check your answers. So we've got 4 lots of 3 times 0.3, take away 2, and that's going to equal 2 lots of 0.3, take away 5. That's that hoop anyway. So we've got 4 times bracket 0.9, take away 2, close bracket. Clear that. 4 times bracket 0.9, take away 2, close bracket. It's better. So that gives me negative 4.4. So 2 lots, that's 0.6, take away 5 is negative 4.4. So the check worked. Okay, so this one says work out the next term of this quadratic sequence. Alright, so what we've got to recognise is that a quadratic sequence creates a curved effect if you plotted the graph of it, and it means that the second differences go up the same. So basically, if I do the first difference between these terms, 3, 6, 9, they're not the same value. So if I go to the second differences, I can see that I get 3, 3, the same value. So a quadratic sequence, the second difference is the same. If it was the first difference, that would be linear. So in other words, it would just be so many x's plus a number or so many n's plus a number. Because it's the same difference, then we'd do 3 there, and that would be 12, because 9 plus 3 is 12, so 23 plus 12 is 35. So we know this is going to be 35. Okay, so quadratic sequences, you have to do the differences twice, and if they're the same value, then it is a quadratic sequence. And you can work out the values all the time by adding up the differences in the terms. Okay, so this one says work out the size of angle X. Well, we recognise that this is a right angle triangle. We need an angle given lengths. That shouts out at us that we're going to use the trigonometric ratios. Trigonometric ratios needed. If it was 2 lengths, we need another length, then it would be Pythagoras, because we've got 2 lengths given, need a third length. In this case, it was a question involving a right angle triangle, and we need to find an angle. If it was a right angle triangle with an angle given to find a side, it would still be the trigonometric ratios. So hopefully you've learnt your sine, cosine and tangents, and lots of you will have learnt this mnemonic, silly old Harry, caught a herring, trolling off Aberdeen, and you'll go through the process of labelling your triangle. So we should recognise that for a right angle triangle, then the length opposite the right angle is always the hypotenuse, the longest side, and the length, let's say theta was here, the angle we're trying to find, and then the length opposite the angle is known as the opposite length, and the length next to the angle that we're finding is known as the adjacent, because that's next to. So in terms of capital letters, that represents H, that represents O, that represents A. So this question talks about finding out an angle in a right angle triangle, so we're going to use one of these. So the first thing we're going to do is label our shapes. So the right angle's there, so opposite length there is the hypotenuse. The angle we need to find is here, so this is the opposite length to that, and the adjacent length is the one next to the angle we're either working with or finding. So we've been given A, so we can tick under here, we've been given A, and we've also been given O, so we can tick under there. And to decide which ratio to use, which trigonometric ratio to use, we find the ratio that we managed to tick twice, and it's the tangent ratio. So we write out the ratio, so the tangent of the angle is going to be the opposite length divided by the adjacent length, and because we want the angle, then we have to use what's called the inverse tangent. So on our calculators, the inverse tangent button looks like that. So we're going to do the inverse tangent of the ratio of the 2 lengths. So the answer is going to be tan to the negative 1 of the opposite length 3 divided by the adjacent length 7. So we make sure our calculator is working in degrees mode, so it'll either show the word deg or the letter D in the screen. That's really important, and once we know that's true, and second function, whoops, right, 10 to the minus 1 of fraction 3 over 7. Okay, so we've got 10 to the minus 1 of 3 over 7 in our calculators. Some of you will press second and the tan button to get the 10 minus 1 because it will be shown above it. This calculator's got it on the same key, so you press it twice to get it. And the answer is 23.2 degrees. So 23.2 degrees. Alright, so normally to cover yourselves, write down quite a bit of the answer off the calculator, but then round sensibly to 3 significant figures. Alright guys, so hopefully that's all been useful. Hopefully I've got all the answers right, rushing that through. But yeah, practice is the way to go. Lots of topics there that keep coming up year in year.